In the last class, we have seen single cycle, and we have seen this data path as well, and we have seen that what this adder does, how PC is PC plus 4, or maybe the new jump address in the next iteration or in the next cycle, and why we actually read this address from PC in the instruction memory, and how we divide this instruction of 32-bit to many subparts like 26 to 31, 21 to 25, 16 to 20, 11 to 15, 0 to 15, or 0 to 5. And we know these two control units, ALU control. Let me drag this onto the Jamboard file. And we do know these two control units is responsible for identifying an instruction. Okay. So by reading the value of opcode as 26 to 31 is for opcode, so reading the value of opcode, and in here from 0 to 5 reading the value of function code, our single cycle data path can identify, actually our processor can identify which instruction it is. After it understands which instruction it is, it performs accordingly, like we have seen for the add instruction. Okay, it performs accordingly. So now we have seen that we have to write the control unit values as well, as these are control unit values, like you can see register write, branch, then ALU source, this ALU source, this ALU up, this ALU up, this mem to register, this mem to register. So whatever the control unit being affected by this instruction, we write down the values. Either it is 0 or it is 1, and for ALU up, it is the operation we do. Like in here, we do the add operation, so it is add in here. Okay, so we have seen plenty of things in here. Today we are going to see some more things. Uh, Before I go to next slide to show you the next instruction, can you guys please tell me what will be the outcome of the single cycle data path? Remember, when I'm going to ask you to draw a single cycle data path for add instruction, we are going to write down the control unit values, all the control unit values, as well as you have to sketch it over. Like few sketching were left in here. Let me show you. We have to show that PC is always being updated with PC plus 4 because there was no jump as branches 0. So we have to add PC is equal to PC plus 4, and there would be this jump. Right? As branch is equal to 0 in here, if one of the input of this AND gate is 0, can you please tell me what will be the output of the AND gate?
Output will be
0.
0.
So
0, sir.
0 means this is the selection pin of this mark. This 0 will go to input to output and come back here in the PC. So whenever there is no jump, we assign branch is equal to 0. So we assign branch is equal to 0 means PC will become PC plus 4. So branch 0 means PC will become PC plus 4. Branch 1 means PC will become actually 0 or 1. I'm going to explain it later. But for branch 0, it is always PC is equal to PC plus 4 as there is no jump. For branch 1, there might be jump. We cannot say there will be a jump. Like even if I write an instruction like this, for example, BEQ $S0 $S1 and a level L. Okay. So if these two registers are equal, or if these two registers value are equal, only then it will jump to L. Otherwise, it will go to next line, which is actually PC is equal to PC plus 4, right? So for this
Yes, sir.
type of instruction, we assign branch is equal to 1. Branch is equal to 1 uh, does not guarantee you a jump. There could be a jump or not. it will then depend on this output. If because if we set this branch value is equal to 1, output of this AND gate will depend on this input. Okay, so we are going to talk a lot about that later. For now, I'm going to go to the next instruction. Okay, so from the slide, if we can understand the add instruction in here, we have understand the add instruction in the Jamboard file, we'll be able to perform this kind of instruction. Okay, do practice this instruction and let me know if there is any problem. The first instruction that we are going to see today is store word instruction. Today we are going to see three instruction actually, one, three instruction in single cycle data path. We are going to override the data path and we are going to write down the control unit value. Remember, when we are going to override the data path, we just cannot touch this blue colored lines. As you can see in the previous example, I haven't overwrite any blue color line. These are control unit lines. You cannot touch them. Okay, so you can only override those lines which are black. So this is that thing. If anyone has problem with the color, can let me know with an email. Okay. Otherwise, it will remain same. You cannot just color override the blue colored lines. Okay, as they are connected to the control unit. So
আর
first
ব্রাঞ্চ
is the,
স্যার
yes, yes.
ব্রাঞ্চ যদি জিরো হয় তাহলে কি তোমার নেক্সট লাইন? ব্রাঞ্চ
What?
জিরো, ব্রাঞ্চ জিরো হলে কি নেক্সট লাইন?
Yes, always, always.
আর ব্রাঞ্চ ওয়ান হলে নেক্সট লাইন হতেও পারে বা না হতে পারে।
Very good, very good. You're very good. Okay, you're getting this topic perfectly. Okay, so now back in here for the next instruction, that is store word. To perform the execution of store word instruction in single cycle data path, to perform the execution of store word, we need to understand how store word instruction works. If we don't understand how store word instruction works, we are never going to be able to do it. So first thing first, we have to see the word instruction in here. As it is of I type, there is only four fields. So 26 to 31, 21 to 25, 16 to 20, and 0 to 15 together. Now you can see why we need 0 to 15 separately in here, because of I type instruction. We need 0 to 15 separately, and in here there is no 11 to 15, because 0 to 15 together means something in here in I type instruction. Now we are going to see how store word instruction actually works. Okay. For example, assume this is store word instruction. What will happen in here? Store word is actually right. Sorry, I think we have this instruction in here. Store word. Store word is actually right. Register to memory. Value will go from this register to this memory. So we need to find out a address, and in that address we are going to write down the value of this register. So we need to read the value of this register. Then we need to calculate addition of this address. Then we need to uh, store this value, read value in this address. Right? Please respond.
ইয়েস স্যার।
Okay. So like if the C like this, A array 5 is equal to B. Assume B is in $H0. We write the value of B onto array 5. And how we calculate array 5? Base address of A array plus 5 into 420. We add these two to get the correct index A5. In that index or in that address, we actually store the value B or S0. So to store the value of B, we have to read the value of B. We have to read the value of S0. And where is S0? It is cross connection. S0 is in 16 to 20, and uh, sorry, yes, S0 is in 16 to 20, cross connection. S1 is in 21 to 25. So we have to read the value of S0 in here, right? For store word instruction. Let me show you. Is there anything for store word? Okay, nothing. Let me write it down for you. For this one is actually for load word. I'm not going to show that. For store word, what operations we need to do? We need to read 16 to 20, right? Please respond. We need to
Yes,
read the
sir.
value of S0. Okay, from the instruction we understand. And where do we read? Where do we read? Out of these five phases in here, these are the five phases: IF, ID, EX, name, WB. I'm going to show all of this again in here so that you can remember everything. And this is our IF phase, IF instruction fetch. And top part of this register read is actually ID or instruction decode or register read, reading the registers in here, ID. Okay. Now the bottom part is actually the fifth phase. So I'm going to come back to that later. And this ALU is actually execution part where we calculate the result, execution. This is related to memory. I have already said that for load word and store word instruction, we are going to use these things. Okay, we are going to use. So for store word, there will be use of this part, data memory. And bottom part, this bottom part of the register is for write back the result to destination register. This is the first phase. This one is the second one. The order will be fixed. This is the third one. This is fourth one in case we have to use it, and this is fifth one. Okay. So for stored instruction, we do know we have to read the value of 16 to 20. 16 to 20. In which part? In register, right? In registers, named register. Remember, the name of the register here is PC. Name of the register is instruction memory. Name of the register is registers. Name of the register is data memory. These are the registers in here. And this is adder with ALU, only ALU marks. These are the marks in here. And these are the two control units, sign extend, shift left 2. So this register has a name register where we are going to actually read the register. So we need to read 16 to 20 in register. Second thing, what we need, can you please tell me? After reading the value of S0, now we need to
Register read.
add these two things.
Yes.
Add these two things. So uh, execute addition operation of where this S1 is 21 to 25, right? S1 is in 21 to 25. So we need to execute addition operation of 21 to 25 and 20, right? Please respond.
Yes, sir.
And in this 20 is in 0 to 50, right?
Yes,
And
sir.
you guys know this is 16 bit, this is 5 bit, 5 bit, 6 bit. So 16 bit, 0 to 15, next 5 bits, 16 to 20, next 5 bit, 21 to 25, next 6 bit, bits, 26 to 31. So looking at these numbers, we can say we have to read 16 to 20, then we have to add 21 to 25 with 0 to 15, then we get an address. And we have to write this value in this address, right? So if we execute this addition operation of these two, we are going to get an address, right? We are going to get an address, but we are going to add these two things in ALU. Because to add, subtract, anything we want to do arithmetic or logical operation, we need to do in ALU. We are going to do that in ALU. And then the third word. What is the third word? After we add this thing, we get a address in here. We have to store value of 16 to 20, sorry, in executed address operation will be executed address. In that address, we are going to store that value, that read value, and we are going to do memory related operations as there is address mentioned. So we have to work in memory, or sorry, data memory. And this is the data memory register where we are actually going to do this. So first thing first, we have to read 16 to 20. You remember, if we have to read 16 to 20, and this is automatically done in this data path. The value of 16 to 20 is in here, right? Please
Yes,
respond.
sir. Yes, sir.
Okay, fine. And you can see in this data path, this value will automatically be read, and that value 21 to 25 will be in here, right?
Yes, sir.
It will be automatically done. Now, what we need to do is we have to add, because this 16 to 20 is automatically read. Now, this is done. This operation is done. Now, what we have to do, we have to execute addition operation of 21 to 25 and 0 to 15 in ALU. To add this 2 in ALU, we have to take this 2 to ALU. So we have to take this 2 to ALU. It is automatically gone to ALU, 21 to 25. 21 to 25. So 21 to 25 is in ALU. Now we have to take 0 to 15 to ALU to add them in ALU. Now I'm going to see where is my 0 to 15 is. My 0 to 15 is in here. And why we are going to use sign action, I'm going to explain later. After the sign action, I'm going to send this in here. It is automatically in here. Now I want this one number pins value as the output of marks to be stored in ALU as input, right? Please respond.
Yes, sir.
To do that, we have to circle number 1 in here as we are going to choose this. So if we do this, what will be the value in here? Okay, ALU source, ALUSRC. ALU source will be equal to 1, right? As this is connected to control unit pins ALU source. So
Yes, sir.
ALU source will be 1. Okay, now this is in here in ALU. Now we need to add them, right? Because we need to execute addition operation of these two values. So we need to add them. To add them, what we are going to do? We are going to give ALU of as what? You tell me. ALU of is equal to add. So I'm giving ALU of as add in here to make sure these two are being added in here. And the result of the addition will be here in ALU result. Now this value is not a value but instead a address, right? Please respond. This addition will be a address, right? Adding 20 with the base address of a array, it will be a address, right? Please respond.
Yes, sir.
So if this is a address, it will go directly to this section, address. Now here we can see two pins connected. One is mem write, writing something to the memory. Another one is mem read, reading the value of this address. But we don't need to read the value of this address, but we need to write this read data to 16 to 20, this read data to value in this address, right? Please respond. As we need to store 16 to 20's value in executed address, right? Value of 16 to, sorry, right? Value of 16 to 20 in executed address, right? Please respond. Is it clear to all of you? We have to, already have read this value. Now we have to store this read value in executed address, right? Please respond.
Yes, sir.
Okay, so I'm going to, and to write something in this address, write something in this address. Like if we want to write something in the register, we have to take the value on to write data and give register write is equal to what. If we want to write something in this address, we have to take that value in here and give memory right is equal to 1. So you can see it is automatically the read data 2 with this line, it is automatically in here. What we need to do, we need to give memwrite is equal to 1. Only memwrite, sorry. Memwrite is equal to 1. So this value will be written in this address. So our last work will be done in the memory operation as well. Now that's important question. Is there any jump in this store word instruction possible? Any jump? Please respond. Is there any jump possible? Look at this instruction. Any jump possible after execution of this instruction?
No, sir.
Where no. If no, thank you for the response. If no, then we are going to set branch is equal to 0. This is the solution for store word instruction. Is it clear? Please respond. Is it clear or not? You have the access of this file. I'm going to drop this file link again in the chat box in case you need. Okay, go through this solution. I'm going to share only that tab in here. So go through this solution and let me know. Take at least 5 minutes to go through this solution. Try to understand the instruction. Let me drop the instruction in here so that you can understand the length in here, how it is working, the size, the ranges. I have dropped everything in the chat box so that you can understand the store word instruction. As opcode is 26 to 31, RS is 21 to 25, S1, S0 is 16 to 20 in here, and 0 to 15 is 20. So try to understand this instruction. Take 5 minutes, then I'm going to go to the next instruction, which is load word. Okay, enough time given. Let me know if there is any problem. Any confusion in the stored instruction? Please respond if you have any queries or problem in the stored instruction. No problem. Okay, so we understand the stored instruction. Now I'm going to show you the solution for load word instruction. I'm going to copy this one again. So this is actually uh, load word instruction. Now you guys please tell me, do you guys understand how load word instruction works? And there is something left to overwrite in here as well, and that is we have to again show there will be sorry, PC is equal to PC plus 4. You guys can hear me loud and clear? Please respond.
Yes, sir.
Okay. Just wait. Let me complete the solution in here. It will be PC is equal to PC plus 4 again. So we have to show that again. As branch will be 0 in here, outcome will be 0, 0 will be going to the output. Okay. Whatever we select from the marks, we have to circle like this, and whatever part the data is going, we have to overwrite. Okay, so this is it. Now, back to the load word instruction. Now, load word. Okay, so for load word instruction, we have to understand the instruction here. What we do in load word instruction. For load word instruction, we read. Okay, read from the memory. So we have to add these two number. If we add these two number, we are going to get a executed address. In that address, we have to read the value. For example, we have to read the value of array index 5. We have to read executed address value, then write back the value in 16 to 20 as S0 will be in 16 to 20. Right? Please respond.
Yes, sir.
Okay. So first we have to read 21 to 25, then execute the addition operation of these two. Then we have to read executed address, read the value of the address, read the value of the address, and store the result on S0. So I'm going to show you in here. As there will be no jump in PC, don't jump in this instruction. We can do this override at the start, doesn't even matter because branch will always be 0 because there is no jump possible in this instruction. So this is the override we need to do in here. Okay, the override. Okay, so PC is equal to PC plus 4, which will be the part, and then we have to read the value of PC. Then we get the instruction. Then we divide it to 26 to 31 to for controlling to understand which instruction it is. By reading the opcode, it will be able to understand it is load word. Now it will read these two values in here automatically. It will be read in here, these values in here, these values in here. Problem is we need not to read 16 to 20. Why? Because in load word, this register is destination register, right? Where we write the value of this A5. So S0 is destination register in here, right? Please respond. S0 is destination, right? Please respond.
Yes, sir.
Yes, sir.
Okay, fine. You have to give me continuous response, otherwise it is really difficult for me to contact the class lecturer. So instead of reading this value, we are going to take this to the destination register part. Remember, all the destination register should go to right register. So to do that, we have to select 0 from here. To do that, we are going to give register destination REG DST is equal to 0. So the destination register is in here. Okay, now what we have to do? We have the value of 21 to 25, and then we have the value of 0 to 15, which is okay. In the last example, I have not explained this sign extend to you. I'm going to explain it now. You can see that 0 to 15 was sign extended, then went to that mark, and why it was a sign extend. I'm going to explain now. Remember, we want to add this 0 to 15 with 21 to 25, right? Please respond.
Yes, sir. Yes, sir.
So 21 to 25, um, okay, 21 to 25 is of 32 bits because it is a register. 21 to 25 is the S1 register. Every register is of size of 32 bits. Our computer cannot perform the addition of 32-bit number with added with 16-bit number because 0 to 15 is 16-bit. That is why we have to use sign extend. Sign extend actually does add 16 zeros to make it a 32-bit number at the left. Okay, for example, if this is my number 101, if I want to make this 6-bit number using sign extend will add 3 zeros at the left to make it a 6-bit number so that the value doesn't change. As 21 to 25 is 32-bit, 0 to 15 is 16-bit, our computer cannot perform addition of these two different size numbers, we have to use sign extend. Is it clear now?
Yes, sir.
Okay, thank you for the response. Now, as we understand the sign extend, so again, we have to use this in here using the sign extend. This value, read value, is in here. Remember from the instruction in here for the load word, where is the word here? We have to execute addition operation of 21 to 25 and 0 to 15 in ALU. Then we have to read that address value and write that value in 16 to 20. So what we are going to do, first we are going to add 21 to 25 with 0 to 15. Now 0 to 15 is going to that ALU using this mask. So we have to select 1 from here. To do that, we have to give ALU source is equal to 1. So ALU SRC is equal to 1. Now we have this address being added in here. This is the address. It will go to here. This memory, data memory, has two control pin. One is memory write for store what we used this, and one is you can see the connection in here, that is memory read. Read the value of this address. Now we are going to read the value of address. To do that, we are going to give memory is equal to 1. Now, if we give mem read is equal to 1, this value of this address will be readed to this read data. Okay. So now the array index value is being readed in here. So we have the read value in here. We have the destination register in here. We want to write this data in destination in this, because we have to read the executed address. After reading the address, we are going to read that value. We are going to write back that value in 16 to 20. Right? Please respond.
Yes, sir.
Now to do that, we are going to actually take this value in here. This is in marks number 1, and this value goes in the output to this input write data. So to select that value from input to output, we need to give mem to register. Mem to register is equal to 1. Now, to write this value in this destination register, what we need to give, you remember from the last class? Register write is equal to 1, right?
Yes, sir.
register right is equal to 1. So this value will be written in here. After we write this value in 1620, our work is done. Now that question, is there any jump possible? No. So branch will be 0. If branch is 0, then output of the AND gate is always 0. Then we are going to select the 0 number input, which is PC plus 4 onto PC. We go to the next line. So this is load word. Please take some time to understand this instruction. This link is already shared with you guys. You can change between the page numbers like this. So I'm going to again share it only for 5 minutes. And please go through this and let me know if you have any questions. Otherwise, I'm just going to explain another instruction, which is BEQ. enough time given. So are you guys getting this single cycle implementations perfectly or not? Please respond, okay? So that I can understand how fast I can move into the next instruction.
It's taking too much time, sir,
What is taking too much time?
to understand the moves from
I
which
think
stage. No.
I'm not going to show you another instruction in today's class. I better give you some tasks to do. That will help you guys, okay? And I'm not going
Okay,
to
sir.
provide any solution for that as well. You have to find it on your own. You have to try, and you can share your screen and show me what you are actually doing. You can try to find the solution with PowerPoint file or whatever you want. You can edit this with a PowerPoint uh, if you want. So let me know your solutions for. Let me share my screen. Just wait. Hello everyone, can you hear me?
Yes, sir.
Hello. Find the solution. Okay, add in single cycle implementation. Okay, find the solution of add and the solution for add in single cycle implementation. Okay, what you need to do, I'm going to give you the hints in the chat box. First, find the field, then try to understand. Okay, first find the mid field, so you'll be able to have the idea about the range, what you need to do, then try to understand the instruction word, then try to execute it on the single cycle data path. So I'm going to give you some time, take 10 minutes, not going to show you another instruction. So I'm going to ask you guys to share your screen or this will be a homework if you cannot do that in time. Okay. So not 10, 12 minutes at 3:05, I'm going to ask you to show me the solution. Okay. So take 12 minutes from now on and find the solution for add instruction in single cycle data path. Do sketch over the data path using the PowerPoint in case you want. Even if you can try Jamboard as well on your own if you want. So do that and let me know. Now you guys tell me, anyone has the solution? Anyone has the solution of this? Or do you guys need more time? Should I give this as a homework? You guys please tell me, what should I do? Are you here? Please respond.
Yes, sir. Give it as a homework.
Okay, I think you guys need to practice a lot. If you guys show no intention to practice, you guys are going to suffer in the class test 3 as well as in the final exam as well. This is very important. If you do not understand this part clearly, the upcoming parts are cumulative related to this one. Okay, so you'll not be able to understand anything in the next part if you do not try to focus in here. So please pay your attention in the class lecture. Do practice at home. Let me know what is your mistakes, what are the problems you're facing when you're going to solve the problems, so that I can help. Okay, so I'm stopping the recording now. I'm going to take the attendance, and this is homework. And I or I add I all three are homeworks.